Hello, good day everyone. Welcome to the stream. Thanks for accompanying. Today we are going to work on a unit test, or maybe unit is not the right word, on a test that is going to exercise CockroachDB in a network situation and problem situation in a network. So specifically, if we have a 3-node cluster, we're going to partition one of the nodes away from the others so that it cannot converse with the other nodes anymore. And while this problem is occurring, we're going to verify that the clients can connect to the remaining nodes within a reasonable time frame. So we have a PR ready from a little while ago that was initially drafted by Rafi as part of a customer case, and then Rafi handed to me the polishing and finishing touches of this unit test. And then back in the days, that was like a month ago, we had some iteration on this, and the test was slightly improved. And then there was some discussion and some review and other things. And then the plan is now to finish this PR by bringing the test code up to date with the latest version of the test framework, because a couple of things have changed since, and then changing the structure of the Go routine that is used for connecting to the server to test for the availability so that it looks slightly different. So we are going to do this today. All right, so as usual, at the bottom of the screen, we have a reference to the PR if you want to follow along. I have already rebased the PR on top of the latest version of the framework, but as you can see in the text editor, there are a couple of problems, of errors. Like in this case, there is a name that is not defined, and that's because we are looking at the code that was written a month ago, and the framework for the test today requires slightly different syntax in some places. And so we are going to before doing anything else, we're going to bring the tests up to speed with the latest framework. So that is an exercise in reading the error messages from the compiler. And the compiler is going to tell us this and that is not defined or is not declared and other things like this. And based on those error messages, we are going to improve the tests so that it looks good. All right, so the first thing here is that we don't have a test structure anymore. We have a test interface. There's another one here. The other thing we have is the cluster. It's not a cluster structure anymore. It's a cluster interface. I need to sneeze. Sorry about that. All right. Next thing, undefined cockroach. So there is no global variable called cockroach anymore. It's a method on the test structure that is returning the name of the cockroach executable. Then we have start args. So it's going to be option that start args. Right. Then we have filepath.abs. Then we have here a function that has been renamed. It's exported now and is for 3x replication. Then we have a new monitor here. I think it's c.new monitor, and we don't have the argument anymore here. Then we have a test spec here. Here we can follow the example from the tests immediately above and below. Like this. That looks good. And it's going to say, cannot use T as type option, blah, blah, blah. Okay, so what's this is telling us? All right, so there is start is now taking the option, so we don't pass the test anymore as argument to the start function. If you hear some thunders, it's because we have a thunderstorm here, and I wanted to leave the window open because I think it sounds nice. All right, now we have a t.l. It is not called t.l anymore. It's called t.capital L, and it's a method. Oops. What just happened? Yeah. This one, this one, this one, this one, this one. You see what we're doing here, just a search replace, and I have to be careful that we don't replace something that is actually not the same. For example, something that we call t.l with a word afterwards. Let's see what the compiler asks us now. All right, we have successfully adapted the syntax of the test to the newest framework. So let's commit this change as the baseline. All right. Now, let's see. We have here a summary of the commit message. It's still okay. What do we need to do? We want to try it out, probably. So in order to try it out, we actually need a updated Cockroach binary. And to do this, we need to build a binary, and this is telling us that we're missing a build tool, so let's install that. I trust it. All right. I do have a bazel. Why is it complaining to me? Maybe like this? Huh. Yeah, so we're creating a CockroachDB binary. So the test we're making is actually not inside CockroachDB. So I'm actually producing a regular build from the latest main code. It's going to take a little while because it probably needs to download the Node.js dependencies, which is always kind of a bummer and takes a little bit of time. Now, thank you for the subscribe. All right, so as you can see, again, as usual, we're seeing a lot of time spent building the web UI, which I don't really think I need. Oh, maybe I don't need all this. Let me briefly try to interrupt this. I think there is a trick. So I'm going to call this cockroach. How is it called again? Maybe like this. That doesn't seem right. Oh, I need to put the Linux in there. Yeah, look at this. I know I don't need to build the UI artifacts anymore, so it's going to greatly accelerate the thing. Amazing. I'm so happy. I'm going to start my little utility to report the key presses. Let's see. Yes, here you go. All right, so this has completed the build, and now we are going to copy the resulting binary to the system where the test is going to run. We also need to do bin workload, I think. Yes. We want both binaries. All right. And workload is there. All right. So we're going to copy this file and this one to the other computer. All right, and here we are going to rename it. All right. All right, now we can run our test. And we do this by saying path is this push test help workload cockroach, and then how is our test named? It's called network authentication. Run. I'm going to stop this. And now we are going to wait. So this test is using a utility called rocheprod. Rocheprod is a program that is able to allocate resources on one of the public clouds, like GCP in this case. And of course, allocating a computer in the cloud is taking a little while, so this is going to take a little while to execute. I think I will want at a later stage to maybe reuse the clusters in the cloud. We'll see. Right now I'm just running the test to verify that the code from 1 month ago still works fine. Then we're going to modify the test, and for that modification we will be able to iterate on running the test locally, so we won't need the cloud resources. And then after we do some iterations on the design, we're going to run the test again in the cloud, which might take a little while, but that's okay. It's taking forever, and I don't know why. Oh well. So the test seems to proceed. The connections are happening. And then the test is finishing now, and it's tearing down the processes and the resources. All right, so apparently the test is completing fine, and it's going good. All right. Now we have verified that the test seems to work fine. We're going to explore the source code of the test to understand what it does, and then we're going to talk about what needs to be changed. All right. So the test here is creating a network black hole, meaning that there won't be anything responding on that address for the leaseholder of a system table, and then it measures, then it, and then validates that the time required to create new connections clusters remains under a reasonable limit. All right. So how does it do this? It's going to, so we're going to have a node count of 4 to more nodes, and it's going to split the set of nodes available, or let's say of servers available on the test, into two ranges. The server nodes where CockroachDB nodes are going to be running, and then one client node, one client server. I think the word node here is actually not very well named. It's okay. Let's ignore that for a second. Then it's sending the Cockroach binary to all the servers. Then it's going to initialize the cluster, and the passing of the secure flag here is going to create node certificates for every node in the cluster. And then it restarts the node. Why do we need to restart the nodes? It's explained here. It's because the logic that creates client certificates gets confused if we try to start to call the start function 2 times when the certificates are not created yet. Is only going to create them for the node specified the first time. So what we see here in the lines here is that we want 2 separate configurations of the server with separate locality flags. Why do we use that? We're going to see that in a second. But because we need separate localities, we need 2 separate start calls. And as I was explaining, the logic for creating certificates the first time around will only create the certs for the node specified here. That's not what we want. We want them to be created for all the server nodes. That's why we do a start first here, and then we stop the nodes, and then we restart the nodes. And by the time of this call here, because the certs already exists and it's not going to try to create them, it's just going to reuse those that already exist, and then we're completely fine. So what we see here, we're restarting the cluster with locality nodes. And we have here 2 environment variables that the reviewer is asking us to remove. So we are going to do just this. For troubleshooting the test, engineer can add the following environment variables to make the rebalancing faster. However, they should be removed for the production version of the test because they make the cluster recover from a failure in a way that is unrealistically fast. So we're going to keep them right now. But we're going to make a note that this needs to be cleaned up in a second. So to do the test. So test refactor. And we're going to remove the envars at some point. So rework the client coroutines. That's the task we're going to work on in a second, but let's continue. Once it does this, we're retrieving the local IP address of the server nodes for passing to the clients a little bit later. So we are going to start the client command at some point later in the test, and it's going to use the server addresses from the inside of the cloud network. Here we're receiving the TLS certificates for the cluster, and we are going to copy those certificates to so we retrieve them from node 1, and we're going to send them to we're probably going to send them to a different node. I don't see that here. Get local. Where do you have a put of the certificates? Maybe we don't. Oh, we don't need that. Do we? Search steer. I don't understand how this works. Local. Why is there they're not being sent anywhere? Because here we're expecting the certificates to only be present in in the nodes 1 to 3 and not on node 4, and later we're going to use node 4. Oh, anyway, so let's continue exploring the test. So this is retrieving the certificates because at this stage here, the client program running on the test computer is connecting to the cluster, and that needs the certificates. Arguably that might not be the case, but because this function requires the certificates directory, we just give it. So it's not the case because the command line is using accept SQL without TLS. That means that this connection here could avoid using TLS. But I don't think that this is supported. Let's see what the interface says. Well, it has a con. Oh well, let's continue. Then we wait for the replication to complete. Then we create a test user that's going to be also an admin user. And then we are initializing the cluster to move the leases of the particular system ranges to node 1. And we're going to wait for 30 seconds for that, using this SQL query to do the waiting. And then once this is done, the cluster is ready to begin the actual test. And so what we see here, we have a little bit of logic. I think actually this wait group is not needed, but we're going to talk about that later. We have here some kind of logic to stop the test when the thing is going to shut down. And then we are here for every server. So again, like the last server number is going to be the place where we run the client, and so we exclude it from the loop. We're also going to exclude the leaseholder nodes that has been partitioned away, because we know that any connection to that server is going to fail anyway. And then we create a connection URL using the server address for that node that has been initialized above. Then we run a client command. And if an error occurs, we remember that an error occurred. And then that is in an asynchronous coroutine. And then we have the main Go routine continues to run while this one is starting up. It's concurrent. And what this does is that it waits 5 seconds for this Go routine to start doing its thing. And then it will partition the node away using iptables commands. And then it's going to ensure that the configuration is restored at the end. And now it's just going to wait for the client coroutine to finish. And that's the end of the test. When this is done, the client coroutines are complete. Then it will verify that errors have not occurred more than once. And then it will just finish for the monitor it will wait for the monitor to complete. I don't know actually what m.wait does. Let's see. Wait, what does wait do? If the test has failed, don't try to limp along, and then it does wait E. And then it does m.wait. Then what does it do? Does it actually stop the processes? Maybe. Oh, there's a monitoring command. Yeah, I actually don't really like this monitor thing. We'll see. Actually don't understand what this monitor logic is for. Let's ignore it for a second. It's complicated. All right, so that's what the test is doing. And the current way this is doing is that we have a loop running asynchronously that is going to do a round robin, like we're going for every attempt, and there will be like forever until the test decides to stop. Below, I think somewhere. What is keep looping? End test. How does it work? And wg.wait. I don't know what the error condition is. When does it stop? Oh, end test. Nah, 20 seconds. All right, that's what we're seeing here. So after 20 seconds, this test here is going to stop. But until then, it will iterate, and for every attempt, it's going to try from all the servers, to connect to each of the servers in turn. And so here we have a little bit of a problem, which is that this is not realistic of the actual problem encountered by the customer. The customer is saying, I have applications that are actually running, that are trying to access all the servers like continuously. And if they fail to connect to one server, they will retry to the same server. And so what we don't really want a round robin here. We actually want multiple go routines, one per server, and send connection attempts to each of the servers in turn. So this structure here is not adequate. Also, waiting for the timeout inside the asynchronous go routine is kind of odd. Usually that is not the way it is done. We actually want to wait for this at the end in the main go routine. So there is a technique to do this. And so that is the area of the test where we're going to do an improvement. I need some water, give me a sec. Hydration is key. Cool. All right. So we're not going to use this wait group anymore. What are we going to do? I'm thinking right now, which order do we want to do things? We're going to remove this. We're going to remove this stick. Yeah, it's not great. Keep looping doesn't matter to us. We will absolutely need a select here, but it's going to be like this. Case. And then we're going to have server this, and we want a loop. So there's an oddity in the Go language. If you use a loop counter inside the Go routine, then it's going to overwrite the loop counter with a raise condition on every iteration, because the variable only exists once in memory. This here assures that there is a different variable every time. Right. We remove this one. This condition that escapes is like this. All right. Then the error count is going away. This one is going to be out. And we remove this. Cool. So here we have a condition missing. We're going to add in a second. Then there is a stop condition missing for the loop here. And then there is a blocking command, and that is fine. And so this is going to be here, that we're going to do a so this channel, to expedite the end of the waiting below in case an error occurs. And here we're creating a context which we are going to wait on here. And this one doesn't cause an error when it terminates. And that's the one we're going to use to terminate the tests. Here. All right. And then here we are going to not do anything because the error is going to happen inside here. So we have a tolerance for at most one connection error per client Go routine. So what's going on here? In the case where, let's swap this condition, it's actually more readable. It's the first time we encounter an error, we tolerate the error, we ignore, and we continue the loop. Otherwise, we actually don't tolerate the error and we stop the loop. And this ensures that we are able to tolerate one connection error per client per server after the server has been partitioned. We also don't want this to wait forever. And so we're going to have a connection attempt every second. All right. All right. And we have here another thing. Cool. We have modified this test. Let's see if that builds. I think it does. I could try to run it locally, right? Yeah, no, all this is going to fail miserably, so I'm not even going to try. All right, let's give this another shot. While this is initializing, we're going to review the different things we wanted to do here. Explore how much the test result changes when removed the envars during server initialization. So we're going to actually completely remove them, because that was too, there is this, it triggers too many behaviors that is going to be meaningful to try to understand. So we did one go routine per server node that is successful. It can establish connections without delay, or if there's a delay, there is no delay afterwards. That's what we are testing. Run longer. Try partitioning multiple nodes over time. That we haven't done yet. We'll see. Yeah, so this one we're going to try out. Yeah, so currently the default login timeout is 10 seconds and the client login timeout is 15 seconds. So I think we're just going to continue using these defaults. All right, so actually we're kind of doing well on our test design, I think. While it's doing a thing here, we're going to review our changes here. Oh, yeah, so this wait at the end here, we need to actually we also need to expedite the wait in case the All right, so there is a failure already. Cool. So here we see already that it took 4 seconds and there was no update from the attempt connection here. So this connection here is not making progress. And we're not printing, we're not seeing the result printed here. So that's kind of a bummer. All right, so where is this error coming from? 318. All right, so cancel test. It's not actually helping us very much, is it? So this is actually kind of a bummer. It's recreating. Maybe I want to reuse the same cluster multiple times, because otherwise it's just going to take forever every time. Cloud, create args, instance type, all this I have already. Cluster ID. Is there a way cluster? Existing clusters we're using running tests. I'm going to use that. Yep. Let's pre-allocate our cluster. It's going to be more comfortable. So what command was used to allocate the cluster to start with? Let's see what it says. Rocheprod create blah blah blah. So here we're going to reuse a cluster that we created in the other section and debug. All right, so we're going to try reuse the existing cluster. We're also going to strip this binary because it's 190 megabytes large, so slightly too much. Much smaller, just 20 megabytes shaved off. Too much bytes. So you see here, we should see the connection at times succeed, and we don't see it succeeding. That means that we have here a problem with the ability of the clients to connect already. So we will need to investigate that. .308. So that's where it fails. Not the first failure. So the first failure is here. 321. Alright, so this M weight here is making the test unhappy. Oh yeah, it is unhappy because the network is blocked. So the poor thing cannot find its server anymore. So we're going to put this into a sub function. So func main test coroutine runs the body of the test, including the network partition, into a sub function. This ensures that the network partition is resolved by the time the monitor finishes waiting on the servers. Here. Like this. And that will be better. Cool. And we can try again. In this kind of work, there is a lot of waiting on processes to run. That is, unfortunately, the reality of troubleshooting distributed systems. And I should be grateful that this particular test doesn't require a very large input to initialize. Why is it taking so much time? This is a bit too long. Oh, I know what's going on. See, IP tables command here have not, to restore the functionality, have not been run yet. So we're going to do that now. Here you go. No, this should work better. Maybe we can see the progress of the test here. Yeah, there is a reception going on. There's a SSH going on. Oh, this failed. Nice. Text file busy. Yeah, the init command from earlier is still stuck. Better. Let's try again. Oh. Is it fine? Yeah, it is fine. It's very humid in the Netherlands today. We have storms, and when it's not raining from the storms, the air is very damp. And not much I can do about this. I wish we had air conditioning, but also at the same time, I wish we didn't need air conditioning. Climate change is a problem. It is still stuck. That is not very good. So we see a cockroach init here and a cockroach start, and it's not making progress. That is not great. What's going on here? IO timeout. Oh, we have this drop here going on. The command we were using earlier to stop the drop was not the right one. The way to cancel a drop is not to add an accept, is to delete the drop. Right? I think -d. D check, yes, that was it. Stupid me, stupid me. Well, ignorant me, let's put it this way. Alright, so I take this command. No, not here. Here. And then D. And then this one. And then like this. And I'm predicting that the initialization works. Here you go. That was all it was missing. And we will need to restore. So we see again, the connection attempt is not succeeding. We don't see any more attempts going on here. That's the problem. And then at the end, we are restoring the configuration, but not using the right command, whereby the test below doesn't succeed. All right, so this was incorrect. Okay. And we're not seeing any progress on this run with buffer thing here. That's a big issue. Why is this connection not going on? It is unclear to me. And so what we're going to do is understand what URL is being used. Run with buffers, that's the one we want. Oh, it doesn't actually... So we're expecting this here to run. It's not running, in fact, that's weird. We're expecting this printf to occur, and it's not occurring. That is the most odd thing here. So we should see here, after the this attempt here, we should see say It's a URL sent to the server. Let's see, I want to keep the IP addresses. So these are our IP addresses. I'm going to keep them aside here so that we have them handy. And we have accept things here. And so we're going to remove these output. One more. There we go. Then we can try running this again. And there is a little bit more waiting. What a fascinating session today. Is there something in the test code here that I'm not seeing properly? Why would it wait here between this print? So we see this one, and that here does not run. That's the most odd thing. So in this one we want to see and we don't see it. Oh, maybe the thing gets confused because we're talking to the same client node. Maybe. Shouldn't matter too much though. It hasn't even started connecting yet. And we don't see any connection attempt in the test. It is as if those routines here have not even started. So that's really very, very odd. We have a server here, server, yeah. And why is that? It's unclear. So what we're going to do, we're going to ensure that there is at least one connection that has been created. did I write this right? Load uint32. Yeah, that sounds right. And then there is an add uint32 probably. Yeah, that looks fine. And then we're going to rebuild this. Oh, interesting. So monitor task failed, runtime error, index out of range with length 3. Okay. Monitor.go. It's extremely strange what's going on here. No cluster to destroy. I don't know if I really want this monitor facility. Maybe we don't want the monitor facility. Do we want the monitor facility? We're not going to monitor the servers. There's too much going on here. Well, while this test is doing a thing, I propose to take a short break because it's been 1 hour, and it's important to take breaks and move the body a little bit. And so let's do this and reconvene in a few minutes. And we'll be back maybe at 10 to the hour. See you. Hello everyone again. We are back on stream. And we are again waiting for our test to do its thing. In the minutes before the end of the break, I added some additional logging here to explain if the test is finishing prematurely. So what we're seeing here is that this wait is because we're waiting for the Go routines here to start, but we don't see anything starting at this point. It's really, really strange. It is as if those Go routines here were just not starting. And here we have, does seem to work fine, but our test is failing. No connection. All right, well, I will commit this change and I will admit defeat for today. We're not going to be able to complete this work, this test today, without help from someone else. This is very sad, but it is what it is. I don't know what's going on, and I don't have enough understanding of what's this test framework to understand why these Go routines don't appear to even start. So it's super confusing. Oh, I got it. Server address I. That's the one that was broken. Yeah, I think that is the cause of my problem here. This variable should not have been I from the beginning, it should have been server. All right, I think we got it. Maybe we got it actually. You see what just happened is that there was a mistake here. It should not have been I, should have been server. And that's for exactly the reason that is aligned here. And the process of documenting each line in the test was sufficient to detect this mistake. And so now we're going to give another go to this. Cool, look at these. The connection attempts are going on. That was the variable that was broken. And then the test passed, and we are happy. A go mistake. So we giving up to spend a little time to document what's going on is maybe sometimes just what's needed to get a test to a passing situation. Success, after all. Then we need to remove the environment variables as discussed. All right. And what did we see in the instructions from the test? Evolve the test, run longer. Yes, that needs to become another test later. All right. Cool. We have completed this task. So 5 minutes ago, we were like, oh, it doesn't work. We have no idea. And there is no way we can complete this. And I was like, okay, before I give up, I'm going to instruct the next person about what we did. Wrote some comments, and just the process of writing the comments uncovered the problem in the code. And the problem was here. I have to use the server variable and not the I variable because Go is complicated. And just fixing that problem makes the test code work. Who would have known? Paying attention, taking a time, making a break, reflecting, maybe doing mindful reading of the code and writing comments to explain the understanding in the code. Sometimes is all that is needed to make things work. That feels great. Okay, actually, this is good. This is good. All right, so this test has made some progress, and we're going to look at the review comments here. This is done. Okay. It doesn't need to be done, actually. All right, let's publish this. So that was our main task for today. I had a secondary task for today, but I fear that this is going to require too much work for the time we have remaining on this stream schedule. So I suggest, in fact, we are just going to leave it at that for today, and maybe start a brand new tasks at the next live stream instead. Lately, I've been maybe thinking about doing more than one live stream per week, and so we need to think about that, because this way we would get more things done. So that was it. We worked on this PR today, we improved the test, we changed the test structure, we verified the test passes, and we're happy with the results. Cool. Well, thank you for following the stream. Thank you for accompanying this experience, and we will see each other again next week. Have a great week, everyone.